Previous class we have seen the order and molecularity of a reaction. So today let us discuss about zero order reaction. So what is zero order reaction? So what is order of a reaction? We have discussed order of the reaction is nothing but what here? The sum of the power of the concentration terms. Okay. So the sum of the power of the concentration terms, we call it of the reactant, we call it as order of a reaction. So in this we are going to have zero order, first order, second order reaction and so on. So now let us discuss here zero order reaction. So what is zero order reaction? So zero order reaction is nothing but what? The rate. So the reaction rate which does not depend upon concentration of reactants, we call it as what here? Zero order reaction. So see here, reaction whose rate does not depend upon concentration of reactant, we call it a zero order reaction. So in this reaction, so the rate of the reaction remains uniform throughout the reaction. So means what here? Uniform means they all will be in unity. Okay, so same. So here, for example, let us consider a reaction that is A gives rise to P. So what is the, according to definition of rate of a reaction, what we can say? Dx by dt. Dx by dt is nothing but what here? The change in concentration of reactants or change in concentration of products per unit time. That one we call it as rate of a reaction. So here R is proportional to P. So where indicates here T, we can say here where dx by dt equals to K. So here dx is equals to K dt. So by integrating on both sides, what we are getting? Integration of dx, integration of K into dt. Why we have written K outside? Because K is a constant. So now integration of dx is nothing but x and integration of dt is nothing but t. So C is integration constant. Here let us consider this is as a equation 1. So for applying, if t is equals to 0, x is equals to 0, then we are getting C value is 0. So now you substitute this C value in equation 1. So then what we are getting here? X is equals to K by T. So what we have to find out here? Rate constant of the zero order reaction. So the rate constant is nothing but what here? K is indicating rate constant. So where K is equals to x by t. So this is nothing but rate constant equation for zero order reaction. And the units we are going to get here, x is nothing but what here? Concentration. Concentration units is moles per liter. Time we are going to calculate in seconds here. Then we are going to get mole into liter inverse second inverse. So this is the units for the zero order reaction. So for each reaction we have to find out the half-life time period. The half-life time period is nothing but what here? The time taken for converting the original concentration of reactant to half of its initial concentration, we call it as half-life period. Means what here? So for converting original concentration of reactants, means what we can say here? For example, this is the concentration of reactant we are taking. So for this we have to reduce it to half. Means 1 by 2 we have to take the initial concentration. That one we call it as half-life period. Then for zero order reaction, the half-life period will be here. So what is the rate constant equation for zero order? K equals to x by t. So for example, it is reducing to half now. So let us take x is equals to a by 2 with t is equals to t half. Why we have taken t half? Because here we are finding the half-life time period. So then the constant value we are getting here, k is equals to a by 2t half. So what we have to find here? Half-life period. Means what time we have to find. So then t half is equals to a by 2k is the value for the zero order reaction. So the examples we can take it over here is H2 plus Cl2 gives us to 2HCl, and when you do decomposition of NH3 it is passing into gas N2 plus 3H2, and also H2 plus I2 gives us to 2HA. So these are the examples we can take it over as zero order reaction. So let us take here graph. So let us see the graph over here. The graph here is, we are taking on x-axis half-life time period, on y-axis we are going to take T on x-axis, concentration of reactant on y-axis, and we are going to get a straight line with a slope. Okay, so this is nothing but zero order reaction. Like that we have to find first order reaction, and also we have to find for second order reaction, and also for third order reaction. So what we have told, zero order is independent of the concentration of reactant. Coming to first order, so what is first order reaction? So first order reaction is nothing but what here, rate of reaction depends on the concentration of only one concentration of the, so see here, only one concentration of the reactant, we call it as here first order reaction. Okay, so here let us take the reaction A gives rise to products. So let us consider some initial conditions, that at initial point A reaches without no time. When we not apply any time, then the for reactants the initial concentration will be A, products will be G. Why? Because it is not reaching. So after time applying, means after reaching the time, so the initial concentration of reactants changes into A minus X, and product will be X moles per liter. At that time, for X moles, the time is reached. So now, according to definition rate law, so what we can say, rate is directly proportional to concentration of A, we can say. Okay, so what do you mean by rate here? Dx by dt, as we know, is equals to Ka, where K is rate constant here. So dx by dt is equals to K into A minus X. Why we have taken A minus X? After time T reaches now, so it is converting as A minus X. Now bring x terms one side and t terms another side. Then we are going to get here dx by a minus x is equals to k into dt. Now integrate on both sides here. Integration of 1 by a minus x into dx is equals to k into integration of dt. So according to max we are having this one now. So 1 by a minus x is nothing but what here? 1 by x is nothing but log x. The same way 1 by a minus x is nothing but what here? Minus log a minus x. Integration of dt is nothing but t. Kt plus c, integration constant. Now you keep x is equals to 0, t is equals to 0. Then we are going to get the c value. If you keep x is equals to 0, what we are getting? Minus log a plus minus log a is equals to c is the value we are going to get. So now this equation substitute in equation 1. So when we are substituting in equation 1, this is the value we are going to get. So what is the value we are getting? When you bring log a to the log a minus x, so kt is equals to log a minus x. So this is in the formula of log a minus log b. Then we can write it as log a by a minus x. So k is equals to, here also we have to find rate constant k. So then k is equals to log a by a minus x is equals to by t. So where ln indicates what here? Log to the base 10, natural log. So instead of writing ln, we are writing here 2.303 by t log a by a minus x. So this is the rate constant value we got for first order reaction. Now the units, if you have been observed here, so this is concentration, this is concentration, moles per liter, moles per liter. So both will get cancelled, and T is nothing but what here? Second. So this is nothing but units of the first order reaction. Second inverse is the first order reaction units. So next, coming to half life time period. So when you see half life time period of a first order reaction, what is the rate constant equation we got here? So that is k is equals to 2.303 by t log a by a minus x. So where t is equals to t half, x is equals to a by 2 if we are taking. Substitute these values in this equation, then we are getting this one. So then a will get cancelled, means 2a minus a means a by 2. So a will get cancelled, we are getting log 2 value. Okay, so what do you mean by log 2 value? Log 2 value here 0.3010. So when you multiply, if it means what here, we have to find half life time period. So that's why t half is equals to 0.3010 3010 into 2.303 by k. So here by multiplying we are going to get half-life time period of the first order reaction. Now coming to graph. So reactant we are going to, concentration of reactant we are going to take it in y-axis, time in x-axis. So then we are going to get a slope here, what here, k. Okay, so this also indicates what straight line it is going to give. So if you take example of the first order reaction here, so the first order reaction examples means the reactant should be 1 here, okay, and product, how many products also no problem, but the reactant should be only 1. So now you have been seen here H2O2 is converting into H2 plus O2. So it depending upon only concentration of reactant, no, at the same way N2O, N2 plus half O2, N2O5, N2O4 plus half O2, SO2Cl2 gives rise to SO2 plus Cl2. So these reactants are 1. These all indicates what here, under thermal decomposition only it is happening, means under heating conditions. So that's why we call it as it is a first order reaction. Now let us see second order reaction. So second order reaction is nothing but what here, reaction whose rate is determined by change of two concentration terms. Means over here the rate depends upon two concentration terms, we call it as second order reaction. So if you have been observed here, we are having two cases for second order reaction. So one is if you take directly as 2A gives rise to products, or we can write it as A plus B gives rise to products is also second order reaction, 2A is also second order reaction, 2B is also second order reaction. So now let us consider first case, that is 2A gives rise to products. So then what will be the rate of the reaction? dx by dt. So when you apply initial concentration at A, the product will be 0. When you apply time here, the concentration will be A minus X and X moles per liter. So now let us, according to rate of reaction definition, write this one, that is dx by dt is proportional to concentration of A square. Why we are saying A square? Because it is depending upon the concentration of the two terms. So that's why when you write it over here reaction, it is converting into concentration of A square. So now removing the proportionality, we are going to get the constant, that is K value. So what is A here? A minus X. So the A minus X we are writing over here in the place of A. So then K into A minus X whole square. Let us bring X terms one side and T will be going on right side. So then you are going to get over here is dx by a minus x whole square is equals to k into dt. So when you do integration on both sides, so means what here, integration of 1 by a minus x square into dx is equals to k into 1 by dt. So as we know, according to Max formula, 1 by x square into dx. So 1 by x square into dx is nothing but what here, x to the power minus 1 by 1. So means what we can write here, 1 by a minus x. A minus x square is in the form of 1 by x square. So when you write 1 by x square integration here, so when you write over 1 by x square, so what you are going to get here, x minus 1 by minus 1. Then you are going to get here 1 by x is the equation we are going. So in the same way, a minus 1 is x is also have written, which is in the form of 1 by x square. So then we got the equation 1 by a minus x is equals to kt plus c. Let us take it as a equation 1. Now you apply x is equals to 0, t is equals to 0. So then we have 1 by a is equals to c. We are going to get the value. Now you substitute this value in equation 1. So what you are going to get, 1 by a minus x is equals to kt plus 1 by a. Then you are going to get what here, kt is equals to 1 by a minus x minus 1 by a. So then by doing LCM everything, a will get cancelled and plus x by a into a minus x. So then we have to find rate constant, no? So that's why we are taking t. K is equals to 1 by t into x by a into a minus x. If you see the units, 1 by T is nothing but second, X is nothing but moles per liter. This is concentration, mole square, liter square. 1 mole, 1 liter will get cancelled. Then you're going to get here second inverse, mole inverse and liter. So these are the units. Now let us find half lifetime period. So if you have been taken X is equals to A by 2 and T is equals to T half, then what is the equation we are getting? Substitute these two values in this equation. Then K is equals to 1 by T half into A by 2 by A into A minus A by 2. So then what we are going to get here, 1 by T half is into A by 2 into 2A minus A by 2 means A by 2 will get cancelled. Then 1 by T half into A. Here we have to find T half value. So that's why T half is equals to 1 by Ka. So it is depending upon the concentration of reactant. So this is one of the half lifetime period equation. Let us see the graph and examples. So what is the graph here? The concentration of reactants will be on y-axis, time will be on x-axis. It will be getting a straight line with slope k. So this is nothing but second order reaction. So let us consider now if we have another case, that is A plus B gives rise to products. So this is A, this is B with 0. After time reaches, this one converts into A minus X and this is B minus X with X moles per liter. Now according to same definition, so dx by dt is equals to K into A into B. Okay, so now in the place of A you are going to write A minus X, in the place of B you are going to write B minus X. So now we are going to get 1 by A minus X into B minus X dx is equals to K into dt. So by calculating this value, by doing integration, so 1 by A minus B, we have to solve this one. So 1 by, according to max we are having this one, 1 by A minus B of integration A minus X minus B minus X divided by A minus X into B minus X into dx is equals to kt plus c. This is the equation we are having. So then A minus B and this, so see here A minus B minus X plus x minus x will get cancelled. So if you have been taken this whole formula, then we are going to get two integration parts, 1 by b minus x into dx minus 1 by a minus x. Why? Because here a minus x will get cancelled, then 1 minus b minus x we are getting. Here b minus x will get cancelled, 1 by a minus x we are going to get when you do LCM. Okay. So according to 1 by x into dx is nothing but minus log x, here also minus log x. So log a minus x by log b minus a. Why? Because log a minus b formula here we are going to have. So this is the equation we got. Applying initial conditions like x is equals to 0, t is equals to 0, we are going to get c value. So the c value is going to substitute in equation 1. So after substituting, what we are getting, 1 by a minus b we are going to take common, and log a minus x, b minus x and minus log a by b. After that, so this is the value we are getting, log a into b plus means log a plus log b is nothing but log a into b formula. So after writing this one, we are going to get 2.303 by a minus b means log b into a minus x by a into b minus x. This is about second order reaction. So here example we can take it as two reactants. Okay, so here ester hydrolysis we can take it. So it is getting two reactants, and here we are going to get, these are the examples we have taken. So let us see next one, third order reaction. The third order reaction is nothing but what here, it depends upon the three concentration terms. That one we call it as what here, third order reaction. Here three conditions we can take, that is 3a gives rise to p, or a plus b plus c, a plus b plus c we can take it as, or we can take it as 2a 2A plus B is also third order reaction, or we can take it as any reactant with these are the three conditions it is going to get. So now let us consider one equation, that is 3A gives rise to products A 0, A minus X, X moles per liter. So here rate we are going to write A cube. A is nothing but A minus X whole cube. Okay, so 1 by X cube. 1 by X cube is nothing but 1 by, when you do integration we are going to get 1 by 2 into a minus x whole square. When you apply x is equals to 0, k is equals to 0, we are going to get 1 by 2a square is equals to c. The c value is going to substitute in equation 1, that is 1 by 2 into a minus x square is equals to kt plus half a square. So after that what you will do, you will do LCM. So after doing LCM, what we are going to get here, so this a square minus a minus x whole square by 2a square into a minus x whole square. So then a minus b whole square a square plus a minus b whole square plus 2ab. So this is the value we are going to get. A square will get cancelled, x square plus 2ax. So this is the third order reaction we are going to get over here. So here T is seconds, mole square per liter square by mole power 4. This is concentration, this is concentration. So we are going to get the units, liter square mole power minus 2 second inverse. So when you have been seeing half-life period, we are going to get T is equals to T half, X is equals to A by 2. Then K is equals to 1 by T half. Substitute these values, we are going to get T half is equals to 3 by 2k a square. So this is nothing but third order reaction, and we are having graph also we are going to have for third order reaction, that is the slope we are going to get k and t on x-axis and 2ax minus x square by 2a square, means concentration of reactants will be on y-axis. So these are the order of the reaction is in the integrated form. Now let us discuss about here methods of order of a reaction. Methods of order of a reaction is nothing but what means we are having half-life time method, Van 't Hoff method, Hochschild method, trial and error method. So first method, half-life method, which is also known as fractional change method. Okay, so for example, if we have been first order reaction, this is the half-life method we are getting. For second order, this is the equation, and in the same way for third order we are getting 3 by 2 into k a square. Means what happens here, the k is constant everywhere, here no a, but here for second order a is there, for third order a square, for fourth order if you take a power 4 a cube, for fifth order a power 4, like that we are same. So means what, the reaction is independent of the initial concentration for first order reaction. Yes or no? Here A is not there. Initial concentration is not there. It is not depending. But for second order what happens? It is depending upon the concentration of the reactant. By this what we can say, for nth order T half is proportional to 1 by a to the power n minus 1 we can say. So for two different initial concentrations if you have been taken A1 and A2, then half-life time period what we can say, T dash half is proportional to 1 by A minus 1 and T double dash half is proportional to 1 by A to n minus 1. So this is the equation we are going to get. So means what, here we are going to speak half-life time period, what it is depend, what it is independent. So by taking here so see here T dash half by T double dash half, then you are getting A2 by A1 n minus 1. If you take logarithm on both sides, what we are getting, log T dash half by log T double dash half is equals to this n minus 1 will come front, n minus 1 into log A2 by A1, log A by B formula, log A minus B formula. So this is the way we are writing, and n minus 1 is equal to, this is the value we are getting. So this n will come this side, means 1 plus minus 1 will come plus here, this is where n is the order of the reaction. By knowing the values we can calculate the A1 A2 T dash of T double dash. Okay, so this is nothing but half-life method. Coming to Ostwald isolation method. Ostwald isolation method is nothing but what? It involves only two or more reactant. Means what we can say here, number of so applicable for reactions which contains two or more reactants, we can say. So for a number of times, how much time it is taking the reactant, how much time the product it is taking. So that's why we call it as Ostwald isolation method. Okay, so means the experiment how many times it is carrying out. Each time take all the reactants except one in excess, we can say. The reactant which is not taken more, that one we are saying that isolated. Means what we can say here, the reactant whatever it is taking more, means time, how much more time if it is taking, that one we call it as isolation. If it is not taking more time, the reactant, that one we call it as isolated. Okay, so the kinetics of the reaction will give the order of the reaction which are the isolated reactants. So for this what we can say here, the order for different reactants if you have been observed. See here three reactants A, B, C we have. Order of the reaction for the reaction N1 is A, for N2 is B, and for N3 is C. So then overall reaction what we are writing here, A plus B plus C gives us to products. So then order of the reaction will be N is equals to N1 plus N2 plus N3. So where N is the here order of the reaction we can say. Okay, so this is nothing but Ostwald isolation method. So Ostwald isolation method is nothing but what here, the reactant how much, means which is not taking more time, means which is not taken in excess, that one we call it as isolated. So next method is Van 't Hoff differential method. So Van 't Hoff differential method is nothing but what here, so Van 't Hoff differential method is nothing but we are saying rate of reaction definition, right? So that whether it is depending upon concentration of reactant or not, that one means Van 't Hoff is nothing but I, experimental by observational. So that one we call it as Van 't Hoff. Now the let us consider rate of reaction whose concentration is here, R is equals to minus dC by dt, which is equals to Kc we are going to write. Okay, where R is proportional to C. So then we are going to get minus dC by dt is equals to Kcn if we take n terms. If we take two concentrations C1 and C2, then the rate of reaction we are going to get here is minus dC1 by dt is equals to Kc1n and minus dC2 by dt is equals to Kc2. When you take logarithms on both sides, what we are getting, log R1 is equals to log K plus n log C1. Why? Because A into B formula, no, this one. So A into B formula means log A plus log B. So that's why we have got this reaction. Log R2 is equals to log K plus n log C2. So when you do minus on both sides, what happens? Log R1 minus log R2 is equals to n log C1 minus this log will get cancelled when you do log minus. So n log C1 minus n log C2. Then what we are going to get here, n value we are going to get n into log C1 minus log C2 is equals to log R1 minus log R2, which is in the formula of log A minus B. Log A by B we can take. So or else we can get n value over here. So the values of R1 and R2 will be calculated by plotting the graph, that is concentration time and concentrations. Okay, so by substituting these values we are going to get the value m. So this is nothing but Van 't Hoff differential method. Now let us see trial and error method. So trial and error method is nothing but what here, here the reaction is carried out about the known quantity, known reaction of the reactant, and to determine the reactants how much it is consumed with time. So the rate constant for first order reaction we have seen, and for second order reaction we have seen, and also at the same way for third order reaction also we have seen here. Okay, by applying here log for first order and second order, this is the equations we are going to get. So where first order will give straight line when you draw a graph with time t, and also second order will give the concentration. So next one, effect of temperature on rate of reaction. This one factor we have already discussed. So once again you see here, by applying Arrhenius equation, so generally when temperature increases, the rate of reaction increases, we are seeing. Why it is increasing? Why? Because when you raise the temperature, the reaction becomes 2 or 3 times more. Means the rate of reaction, it is increasing. So for example, how we can say here, when you apply some heat, it is giving some value, enthalpy equation. Okay, so here it two temperatures, that is for every 10 degrees centigrade, it is denoted by specific rate constant. So Arrhenius equation is, apply Arrhenius equation, that is K is equals to AE to the power minus EA by RT, where A is Arrhenius constant, temperature, gas constant, activation energy. If you take two different temperatures, we are going to get K1 and K2. When you apply logarithm on both sides, we are going to get this value. So when you do minus, so this is the equation we are going to get. So next one, collision theories. So next one is what here, collision theories and transitions theory. What is collision? Collision is nothing but bombardment. So when we react with reactants and products, reactants, so it is going to form the products. Automatically it is not going to form the products. In between there is a formation of colliding. So means what, there is a formation of intermediates. So means what happening, the molecules, the reactant molecules will collide and it will form the products. So that is nothing but collision theory. So here we are going to consider threshold energy, activation energy. So this is all coming here. So let us consider the conditions. The first condition is the molecules of the reactants must come near, collide with each other. Right. So means what, when the reactant molecules are colliding, they come each other. Okay. So that is the first condition. Second condition, at the time of collision, the molecules must carry some amount of energy, minimum small amount of energy when they collide. That one we call it as threshold energy. So this must be oriented properly. So when collision is happening, so the breaking of the molecules should be happen properly. So then what happens, the reactant molecules will be in a state of continuous motion when they collide with each other. After that, the excited bond, means the excited bond will be distributed or broken and they form, and a new bond is formed, that is nothing but here product is going to form. So by this what we can say here, all collisions do not lead so means what we can say, all collisions which do not lead to, means when we are colliding, every time it is not going to form the products. So only such collisions which can form the products, that one will be only under the activated molecules. So that one we call it as activation collision. Okay, so activated collisions leads to formation of products, we can say. So the active molecules have some amount of energy, that one we call it as activation energy. So means what we can say, the minimum amount of energy with reactant molecules to undergo a chemical reaction, we call it as threshold energy. We are saying the molecule which do not possess threshold energy cannot give products, and the collision between such molecules which undergo collisions according to kinetic theory, so always do not produce amount of kinetic energy. Many molecules will have lower energy than required minimum threshold energy, that one will bring a chemical reaction. So let us take here equation, that is K is equals to ZE into minus e power a by RT, where EA activation energy, R gas constant, T is temperature, Z is nothing but collision number. So this is the number pi n square h square by root over a pi kt m into mu bar. So this is nothing but activation energy we are having. So here which is having lower energy than threshold energy should require some amount of energy, that one we call it as activation energy. So this is the graph we are having, that is reactants and products. Here exothermic reaction, endothermic reaction is going to happen. So this is transition state which is going to form as intermediate. So this is the transition, this is activation energy, this is products, where activation energy is nothing but threshold energy minus real energy, we can say here. So then transition state theory. So this is the second theory. So in this theory what happens, the reactant molecules direct not converted into products. So what happens here, first intermediate is formed, after that it is converting into transition state. After forming intermediate state means which is known as transition state. So the molecules which possess more energy than threshold energy to form activated complex. The activated complex is energy barrier between reactant and products, we can say here. Here reaction we have taken over here, that is, see here Hi plus Hi gives us to 2Hi. So distributing factors means what happens here, the molecules are colliding with each other. So what are the factors we are having for order of the reaction, side chain reaction or parallel reactions. So here what we can say, sometimes the reactants which undergo two or more independent reactants at the same time, those reactions are known as parallel reactions. Means what here, alkyl halide KOH. So both are happening simultaneously, that one we call it as what here, parallel reaction. So here sometimes the side reactions become negligible, this one should be negligible. Why? Because here the side reaction converted as the main reaction at suitable condition. So reaction between ethyl chloride KOH form ethyl alcohol when alcohol aqueous KOH is used. So then what happens here, ethylene will be formed when alcoholic KOH is used, right? SN1 and SN2 reaction. So this is nothing but side chain reactions. Consecutive reaction. So this is very common and important in polymerization reaction, we can say, and also depolymerization reactions. So reactions which is having higher order complex in nature, it will take place in certain stages. That rate coefficient is defined by slowest step, which is known as rate determining step, we are saying, right? The first step, slowest step. So if you have been observed here, 2NO2 plus 2H2 gives us to N2 plus H2O. Okay, so after that 2NO plus 2H2 gives us to N2 plus H2O2. This is the slow step. After that what happens, H2O2 plus H2 gives us to 2H2O. So this is the fast step. So this one we call it as rate determining step. Next one, opposing reactions. So opposing reactions is nothing but reverse reactions, we can say. So all reactions are reversible and they acquire equilibrium also after some time, but in many cases the equilibrium position will be on the product side only. So let us see this equation. So these are the different types of reactions. Now let us see pseudo first order reaction. Here when you have been observed, pseudo order reaction is nothing but, we are saying here the reactants is 2 but the order will be only 1, that one we call it as pseudo first order reaction. So example, if you have been seen here, hydrolysis reactions in neutral or acid solution of the first order. So here amount of water used here required for reaction, here acid acts as the catalyst and not used by the reaction. That's why we say it is as a first order reaction. Okay, this acid will be used by water but not this one. So this one only depending upon the reactant. So above reactions two molecules are used, right? But we are saying unimolecular. Why? Because here water remains same during the course of reaction also. That's why we say it is a pseudo order reaction. So this is nothing but chemical kinetics. In the next class we can learn about the Michael-Mentens and enzyme catalysis. Thank you.